Okay, so now I'll be recording my solution for word search problem. Um, I was solving that couple times in the past. Um, so like the latest try was like 2 years ago, and it was in Java. So let me try to do that now and record my attempt, and we'll see how it's gonna go. So it seems like it's a DFS problem. Might be like also solved with BFS. But the problem is that I have to track the path. So like uh, in case of BFS, for the every trajectory in a queue, I have to keep like all this like letters in the trajectory. So like I don't step on those that are already in trajectory. Um, and it might be a little bit verbose and like uh, might be too much. So I'll first solve it in with DFS, and then if time permits, I'll be solving with BFS. So right now I have this idea to have small optimizations. So like, let's say we have this map um, A, B, C, E, and then S, F, C, S, and then A, D, E, E, and then I need to figure out if it contains the word A, B, C, C, E, D. So there are like two candidates to start. Like the first one is this A letter, and the second one is this letter. So and then I need to start like doing the traversal. So I need to like check the neighbors, and the next letter is B. So I need to check the neighbors and which one has a letter B, and that the neighbor is like this one B. And then next one is C. So I check again the neighbors and like don't include the already visited nodes. So in case I have A, B, A, I cannot go back. So I'll have DFS um, with the path tracking, so that um, if I have, let's say, A, B, and B here, and then let's say A, so in case I already have A, B, let's say C, so I don't return when I jump from A to B, I don't return to A back, because it's already like in a trajectory and like it's cycle, and cycles are not allowed. So in this case, I'll go A, B, C, and let's say something like this, A, B, A. Let's say I'm looking for A, B, A, yeah. And then let's say we have B is this side, and then on this side I have, let's say, C. So, and I need to figure out if the AB is included. So if I just say, okay, let's allow revisiting the nodes that are already in the trajectories, means like I can start with A, go to B, and then go back to A, and then maybe go back to this one, B, maybe go back to B this on this side. So like I'm not allowing this one. So in this case, A, B, A should not be A, B, A, B shouldn't be found. And it should return false. So in this case, say we have pointer C, and then I can traverse. There is only one neighbor that hasn't been visited that has C, so I go to next C, and I go like, okay, next C is like here, and then I go to E, and then I go to D. So this one I managed to find this letter in the grid. So I need also to figure out if I can let's say I started not from this A, but from this A. And then I'm gonna, okay, I added A, and then I check if I can find B in this case. And it seems like there are no neighbors that have like B letter on them or like on cell. So it means that I have to cancel my search and like fall back to other options. So that's gonna be my sketch. For the DFS, I'll also mark the grid with a safe star when I to track the path. And then initial I'll scan the grid and I'll have the map for the let's say letter, let's say A, and then the key gonna be A, and then the values is gonna be I and J when we have like A and current. So it's gonna be for the A here it's gonna be 0 0, and then the second one gonna be 2 0. And that's how I can like efficiently or like like the most efficient way to find the starting point. For sure, I can like scan the grid every time I see a word and like find it. But yeah, let's split it. So I have this DFS function that's gonna have DFS, and then I'm gonna accept the board, and then I'm gonna have I as a int, and then J as a int, and then I'm gonna have the pointer, so I'll mark it word pointer, and that's gonna be int, and then the word itself, word as a string, and then I'll return bool if I can find it, or else like I'll return like true if I can find the path, or like path for this word on this board, and I'll return false if I cannot find it. So I'll go, let's say we have years equals this array minus 1 0 1 0, then here 0 minus 1, and then 0 1, and then I'll go for dir in dirs. I'm gonna check next I gonna be I plus dir 0, and then next j gonna be j plus dir 1, and then I'm gonna check if next I less than 0. Here I'm gonna have rows calls equals board. Can the board be no, board starts rows and columns starts with 1. So board gonna be len of the board, and then the second one gonna be len of the board 0. So if next I is less than 0, or next I is greater or equal rows, or next j is less than 0, or next j is greater than equals calls, then I'll do continue. Otherwise I need to check if the index and the next line xj, if the character and the next line xj is matching word next pointer, and then actually if the word pointer actually I can move this one, check. So if word pointer is equal len word I'm gonna return true. Otherwise, if word pointer and then word pointer is equal to the board ij. If it's not equal, I'm gonna return false. Not equal, then return false. And then here rows calls next line j, and then I'll go if it's like temp, it's called teacher for the ch equals board next I next j, and then I'll put the board next line j equals so here I need to basically to mark it, so it means that if another one, if word pointer and then +1 let's say so I'll launch it for the A, and it's gonna be I and J, and then I need to check if there is matching letter on the next neighbor, and if there is matching, I should go into the DFS. So so like this, if word pointer, if word if len for the so here that was correct. If len for the word is equal to the word pointer, I'm just gonna return true. Return true. And then here return false, and then temp character equals this one, and then I'm gonna call board next I next j gonna be equal just star, and then I'm gonna call DFS I next j word pointer +1 board, and then board, and then res equal, and then if res I wanna return res, and then I'm gonna reconstruct the board. So board next I next j gonna be equal temp character, and then I need to call this actually function DFS. So I'm gonna go for I in range rows, and then for j in range calls, and then I'm gonna have what I'm gonna have this map equals this one, then I'm gonna it's called default dictionary, and then list here, and then here I'm gonna have for ifj, and then m board I j add ij, and then for initial point in m dot if m dot get word 0 is none, then I'm gonna return false. And then for I need to go through this for initial point in m word 0. I wanna do res equal dfs IP 0 IP1, and then the board itself, board, and then and then ij word pointer. So word pointer gonna be 1. Word pointer gonna be 1, and then I'm gonna pass a word, and then the word itself, word, and then if res, I'm gonna return true, otherwise here return false. So that should be it. Check if I have any mistakes. Then word, then okay. Word 0, okay, initial point. So I can also do ij here. I can do ij to avoid confusion. Ij. Oh. Default dictionary. Can I do list like this? For I in range. Rows. Okay. It's gonna be initialization here. Append. Wrong answer. False. Do I ever entered this function? Print. So f h. Okay, so here word pointer, just word pointer. So let me just describe the word pointer gonna be the current word pointer, and then I'm gonna check here word pointer +1, and here not equal next I next j in a word. So let me call it here. Where does it break? Next I less than equal 0, next I greater than equal rows, next j greater than equal calls. So here I should do if len of word plus, if word pointer is equal length pointer +1, No, it's still so the exit is interesting. How I should do exit? Let me do this one. If len is equal word pointer, and then here I wanna do word pointer, and here pass 1. False, and so in all cases it's false. So I assume it's somewhere here. So print f temp character gonna be equal temp character. So what we have here, temp characters never printed. Print here, print f years. So seems valid. And then for during years, next I plus dir 0, next j dir 1, word pointer. If so let's say white never here. So let's put it temp so word pointer gonna be this one, and then board ys board avs. Okay, for dir and dirs, dir 0, let's say next I, next j I. Oh, not continue. Continue, I just wanna continue. Word pointer plus 1. Okay, bug. Okay, I guess it's gonna work now. There was a bug here, I didn't notice that one. A lot of back and forth. That's interesting. Let's use this case. I'm marking it with the stars. Why it is still doing that? In the end, I want to return false. Can I do that? Next I, and then next J, gonna be next J. Let's find it. Why there is a bug? So let's check for I in range. In theory, it should not even like, so it should go through the directories. And it should be, so like A should be marked as star, and then I go to A, and then it tries to go back, and then it ran out of, it should run out of the options and should fall back to false. So let's say have A, double A. So I start with lowercase a, the first one. So if I do that, if len word is equal word, let me check the timing. It's already 28 minutes. How this can be solved? What I really want to print here is a word for I in range rows, for J in, okay, so it's gonna be, let's say R and then C in range goes, and then go board print, and then F, and then here board R, and then C, then comma, and then and it goes this one, and then print just this one. Range. Oh, that's that's interesting. Interesting bug. So I didn't mark when I started the iterations. That let me think that maybe it's a word. So I can think about, I can like mark it right now, and it should be pathing, and then I should probably design API that should be like more flexible, or like not relying on the like whether like user of that API marked the node as visited. So let's do board. So temp character equals board ij, and then board ij gonna be equals star, and then here I need to reconstruct the board. Board ij should be equal temp character. So let's run it. Submit. So let's go. Output limit exceeded. Submit again. Yeah, that's it. Let's check what these people are doing here. Okay, nice. This one is interesting, but it has DFS inside. Exist. If board, okay, he is, instead of like saving it in a map, he just went and check, and then he has like this visited set, and then because it's tuple, he can like track it. I don't know, I don't like this API, but otherwise you should track if the last checked character is actually the last in if it's last in a sequence, if it lasts in a word. So I don't like this one when I do this and that. So let's go for INJ. If so, I'll just call for INJ. I just wanna like do this res equal DFS, and then I'm gonna return if res. I wanna just return true. Then word pointer is going to be 0, and then in the end I want to return false, something like that, to be the maximum efficient. And then the API should be, I want to visit IJ and I want to check if it's like the word is right. So here I wanna rewrite this part. So let's move this somewhere outside this area, and then move this also outside this area. And then I wanna do what? I wanna do check if INJ is equal word pointer. So if word I and then j is equal word and then word pointer. If it's not equal, I want to return false. If it's equal and word pointer equals len of word -1, return true. Otherwise, I want to do this following. I want to do board, so temp character equals board I and then j, and then I want to have this rows and calls, and then next time j, continue, and then this one to be removed, this one to be removed. I want to mark the current current cell as a star, and then launch these iterations, and then the result of equals dfs next line xj, word pointer +1, okay, and then board and word, if res return true, and then I want to reconstruct the board here and then return false. So this one should be more compact solution. It should fit on a screen. So let's check if it runs. Board ing. I want to reconstruct ing. So I want to remove this one also. Let's put it here as a general one, rows and calls, and then remove this one, and then yep, something like this, and then let's submit again. Yeah, kind of the same, but like code is much cleaner. Okay, and what people are doing here? So DFS, if it's okay. I like this style, yes. And then so he's using this visit that. Okay, let's go. Okay, def exist. It's gonna be much old. Okay. Yeah, it says. So what the trick here? Word count collections. Oh, okay. He got the early exit where he just used kind of C bridging, and this functions probably very efficient in a Python. And then he says, okay, I need word count. Okay, word count C plus equal 1. Okay. This one some interesting magic trick he does with I thought it's like board involved, but it's not. Like there is no board here. So this check oh, I got it. So he's saying, okay, should he start doing search from the start of the word or from the end of the word? And if the number of characters from the start of the word is great as the number of so like let's say the word starts at so definitely he just reversed the word and like have this. I don't understand why it's that important like to start with the end that has like start with a letter that has a less frequency in a word. So he checks like the letter that's the word starting and the letter that's the word ending, and like if the frequency of the letter that's word starting is greater than the frequency of the uh, of the letter that's word ending, he just starts from the end of the word. We'll start with less frequent letter. Why it is that important? So if I add this condition to my solution, let's add so we have this one piece of code. Let's say I have this submission, just mission 6 minutes, 12 minutes, is it mine? I guess it's mine, but I don't like this one, so I'll go with this one because I more like it. And then can do this and let's check if it still runs. Okay, something like this. One count. Let's check if it's also gonna work for my code. Yeah, it works. But why? That's a good question. Why? Why I should start maybe in integer? Okay. Oh, that's solution. How to do that without space? Okay, so basically do Luxor.
I saw you eating candy yesterday. I saw you eating chocolate today. What are you talking about?
I mean hard candies.
Yes.
Does anybody have anybody did
That long time ago?
BFS?
Yes, that's a long, long time ago.
Pick it up. That's how math is created.
So this one is also seems like BFS. So I have in mind this optimization when I see the how to do the counter in Python. Python counter function counter. Okay. So I'll have this counter, and I'll feed that counter into my solution. Where is it? Yeah, that's it. So I'll do this counter, and then I'll feed it word, and then see word equals this one. And let's print format c word, and then c word here. What's gonna be c word on c word counter. Okay, and then I need to do, can I do c word c dictionary equals counter, and then I wanna feed this board. Can I do that? And c dictionary, then gonna be c dictionary. Okay. Let's do that. Join 2D array rows Python array concatenate. Okay, no, not concatenate. Numpy. Can I do Okay, so something like this. Let me call this one, this one, this one. So I'll have 4 row in board, 4, so it's gonna be 4 call for the item in this. But like this one is fun. What can I do here? So 4 item inner list, 4 item in inner list, 4 inner list in out list, 4 row in board, something like that. Let me do that. 4 item in 4 row in board, and then I have this 4 item in row, and then I'm gonna have this item, something like this. Check it out. C dictionary counter A2. Okay, in case if this one. Okay, that's what I needed. And then I wanna compare if C word So I wanna have 4 C word, 4 character in C word, keys, for character and frequency in C word items, I guess. Or like, is it enumerate? Okay, let's go search. Enumerate. Compare. Okay, so enumerate hash map in Python. It's gonna be something like for intersect sorted enumerate. Okay. So I guess it also supports some kind of if compare to counters in Python. One includes another. Okay. If C word, but it can be like it can be like, oh, okay. So let's just write it. If C word is less or equal C dictionary, I'm gonna return. If C word is not, return false. Can I do this? And I can do the same counter here. Word counter, C word counter here, and then this one removed. If word count, if C word word 0 greater than 0, then okay, that one, and then check this. Yay, 6 milliseconds, and even without this fancy optimizations, like like people do here with hacks. So can I do my channel watermark? Let's go content, let's go here, let's go path or fail IO, SEO optimization, submit. Submit again. I still don't understand this trick with why I should reverse the word, why it's more efficient. If I gonna just remove this logic, let's remove it and just submit it. How it's gonna perform? Oh, it's much worse. No. It's much worse. So it makes a lot of sense to do that. But why? memory is like so. What people do with memory here? So they do stack. They do so it's BFS, and they have visited set that's stored in so it's like BFS, and the BFS gives you better memory. So if I take this solution and paste these two hooks, let's go, and then I paste this hook and this hook, default dictionary, what is this? I have no idea why I'm creating this here. Okay, so I'm pasting these two hooks, and then I'm removing this one, and then here, okay, yes, of course, and then I am trying to do this, run, submit. Yeah, memory 64%. Let's, if I do, let's say memory here. Yeah, but if I exclude those two hugs, what's gonna be the memory? Oh, what's gonna be the time? Sheesh. That looks like a research video. How to break the Leetcode. So the time is not that good actually for the BFS, but I can improve it and make it like stellar. But using this like two hugs, and like I assume like that one is pretty efficient because I guess it's calling C functions, and this one also one, and then I'm checking if like one is included into other, like if it's like if C word counters is a subset of C dictionary counters.
Me and you can go and order a taxi.
Even 0 milliseconds. That's ridiculous. I wonder if I use a Python or C++, what's gonna be the memory. So let's check memory C++. Backtracking. Let's use this solution, then paste it here, remove my watermark, C++, run, submit, and this shows better memory still, but like the time is not that good. Yeah, that's interesting task. So I guess already over time, it's like over 1 hour, like close to 1 hour. So I'll probably do word search as a follow-up, word search 2 as a follow-up, because it's an interesting one. I remember I was struggling with it like a couple years ago, and like even 5 years ago. So I'm interested to see if I'm gonna be able to solve this time without any hiccups, or there will be still problems. So let's assume it's like gonna be, let's hope it's gonna be better than the than the previous time. Yeah, so that's gonna be it.